Hello, everybody, and welcome to Emory Climate Talks. My name is Eri Saikawa, and I'm an associate professor of environmental sciences at Emory University. And I also serve as the director of science policy and community engaged research at the Resilience and Sustainability Collaboratory. We are going through a lot: Delta variant, war, forest fires, extreme heat, and hurricanes. It is great that the Biden administration is unleashing a spending spree, but it also appears that states might not be able to handle them. There are so many issues that are so complex. As usual, I am very glad that you're here today to discuss what the potential solutions might be for this very complicated problem, or a set of very complicated problems. Emory Climate Talks is made possible by our anonymous donor that supports our trip to the United Nations climate change negotiations. And Emory Climate Talks is in partnership with the Department of Environmental Sciences and the Resilience and Sustainability Collaboratory at Emory University. Thanks to his support, we have had a brand new website, climatetalks.emory.edu, that I hope you had the chance to check out. As usual, I would also like to thank Leah Thomas for doing all the work behind the scenes for the website and for Emory Climate Talks in general. Thanks also to Kiara Brust, who is a new Emory MPH student. We have now a Facebook, Instagram, and LinkedIn pages as well. And so if you have not checked them out, please do. And we hope you will be able to engage with us outside the webinars as well. Before we go into today's program, I wanted to talk about some of the logistics and thank all the listeners for your support. Obviously the speakers too. Please use the chat function to address any questions you may have to the speaker at any point during the talk. We will have the time for Q&A at the end after the presentation. And most of Pat's talks are on the YouTube channel, and you can subscribe at youtube.com/c/Emory Climate Talks. And today's talk is recorded and will go online in a couple of days as well. So I am so excited that we have Dr. Jason Kuiper today at Stepan Company on specialty chemicals that he's going to talk about. I think that is so essential for making our society sustainable. If you have not heard, Dr. Keiper is an Emory alumnus, and he received his Ph.D. in chemistry in 2000 from Emory. And he held a postdoc position at the University of North Carolina, Chapel Hill. I'm sure he will tell us about his journey to his current position in his talk, but Dr. Keiper has been at Stepan Company and at Syngenta. At Syngenta, he held several roles in product development, eventually leading their product technology and engineering team globally. He worked at Stepan first, actually, after he finished his postdoc, and rejoined after Syngenta in 2019. And he has been responsible for Stepan's global R&D teams and sustainability program. Stepan has been our major partner with Emory University and the Resilience and Sustainability Collaboratory. You can read the article about that in the chat if you have not seen it yet. I have to say, I wish I was able to meet Dr. Keiper and hear his work when I was an undergraduate studying chemistry and biotechnology, because back then I really could not really see the best link between chemistry and the society. And I think that's why I moved on to doing chemistry in the atmosphere rather than doing synthesis. So Dr. Keiper, thank you so much for taking the time to speak with us. I love the work you do, and I'm sure you're going to hook all of us up to chemistry that you do. The floor is yours.
Thank you so much. Hello, everyone. And it's great to be with you today for the climate talk. And thank you also, Professor Saikawa and Emory, for the invitation to participate today. So today I'll talk about sustainability from the perspective of a specialty chemical company. And we sit in the middle of a value chain, and I'll talk about what that means a little bit later. But first, I'd like to thank everyone for joining to engage on this topic. It's kind of a long-winded title, so I appreciate you just even taking the step of joining us today, and hopefully we'll have a great Q&A later on as well. So I hope everyone can now see my screen, and I'll do my best to navigate the slides while we're going along. First, just a little bit of background, and thank you, Ari, for the kind introduction. So a little bit more background on myself. My wife, Bessie, and I are graduates of Emory University, and we received our PhDs from the Department of Chemistry. I'll speak quite a lot today about the topic of surfactants. And if you had to ask, who I am or what I am from a science perspective, what's my identity, I would say I'm a surfactant person. It's been something I've had the privilege and opportunity to work on since my undergraduate days and my time at Emory as well. A little bit about surfactants, just to connect to my background as well. Surfactants are surface active agents. These are compounds, chemical compounds that have both an affinity for water as well as an affinity for oil. So if you look at the cartoon on the right-hand corner, the circles being a part of a chemical that has an affinity for water, and then the lines, the squiggly lines, affinity for oil or something other than water. That's what a surfactant is in a really cartoonish way. And I've had the opportunity since, again, my time at Emory and onward to really work in research and development and product development having to do with surfactants. These are molecules that self-assemble, and they're used in a wide range of critical applications globally for cleaning, for disinfection, and very visibly recently to help deliver active ingredients for vaccines. So sometimes you don't think about the importance of these types of chemicals, but they really are everywhere and are important to sustain a lot of applications in our society. A couple other notes, you see that green image right in the middle, that's actually what we would call a liposome, where there's a fluorescent marker and these surfactant molecules essentially make an empty shell, a type of like empty cell to think in other ways. And this is a mimic of how researchers can use surfactants to study biochemistry and as well as the biophysics of cell walls. And that was part of my research at Emory. And on the right-hand side is another way that surfactants can self-assemble in actually supercritical CO2. So it's a really fascinating and fantastic area of research. And again, I'm blessed to be part of this type of research throughout my academic and industrial career. I've also been really fortunate to work in areas of science at institutions and companies that have fantastic and inspiring people. At Emory, I was part of Fred Menger's group, now an emeritus. I worked with Jody Simone, formerly of UNC, on the supercritical CO2 work. And I've been very fortunate to be part of Stepan Company twice in my career, as Ari noted, based outside of Chicago, and then spent time with a great team at Syngenta between that. So an important part of my job currently is our sustainability program. And as Ari mentioned, Stepan's partnership with Emory and the Resilience and Sustainability Collaboratory is something that we're really proud of. We're proud of the association and really pleased with the work and engagement that we've had so far with the Emory RSC team. And we really look forward to supporting the work that forum is going to progress. So just a little bit more, Ari asked me to talk just briefly about my career journey since Emory, and I just want to summarize a little bit the way I kind of reflect back and see it. I think I've had the opportunity to move from individual challenges, so making pure molecules, developing test methods, writing papers, validating hypotheses on narrow scientific topics, to move on to really developing products and making things that work better. So being part of collaborative teams to improve technologies from what exists, and now really working with teams that have to do all of that, but also making things more sustainable and providing environmental and social benefits that will be lasting. And I suspect this will be where I land for the rest of my career, however long that will be. But I'd really just encourage everyone, and especially younger scientists, to think about the broader implications of the research and development work that you do, the exploration, which it sometimes can really be very highly personal and introspective, but there's a lot of satisfaction, I think, that you'll get with really bringing that together with the greater good for future generations. So that's just a little bit about me and my journey. I'm happy to talk more about that later on as well. So on to the main focus of today's climate talk. And I want to first just frame out what are specialty chemicals. We hear every day about the serious issues of climate change, how corporations and institutions are trying to develop goals and viable plans to address emissions, reduce energy consumption, and find cleaner alternatives to products and industries that have contributed to our current challenges that I already mentioned. From a chemical industry perspective, we further hear a lot about the societal and environmental impact of companies that are either at the interface with consumers. So you think about pharmaceutical or consumer goods companies, or the environmental impact of upstream chemical manufacturers that are involved in extracting materials or converting those materials and commodities like petroleum, natural gas, and palm oil. But I'd like to talk today about companies like Stepan that are in the middle of the chemical value chain. Value chain is progressively taking those commodity or basic materials and in each step converting them into something that has higher value as they move towards end use. And we sit in the middle of the chemical value chain, in between those two ends of the spectrum that maybe you most often think about or are more familiar with. And there are some unique challenges and opportunities that we have as manufacturers of specialty chemicals and intermediates. Again, we're not household names. Stepan and some of our peer companies are not necessarily household names, but we play an important role in this value chain and providing products that are used across a wide array of applications, some of which I'll talk about in the next slides. And these companies, like Stepan, have a very important role to play in our sustainable future. So in this slide, I'm trying to depict in a very generalized way what the chemical value chain looks like. And I provide up top a definition of specialty chemicals. And really, again, one of the main things to think about is specialty chemicals is really a diverse area of the chemicals value chain and chemical production. But it sits in between what you see on the left-hand side of this slide, upstream raw materials like palm oil or soybean oil that you're familiar with, natural gas, petroleum, the companies that then take that and convert into basic chemicals, things like ethylene and fatty acids and vegetable oils that are extracted from those commodities. And we sit between those groups and then the companies that convert products or formulations into consumer products or industrial products, that package them, that ship them in distribution across the world in various geographies, and eventually get to the end users, consumers, folks who use industrial products with chemistry to coat paints or build buildings, farmers who use agricultural products to improve the yield of their crops. And specialty chemicals companies like Stepan are in that middle, and we convert those products, essentially translate the very basic chemicals that don't have a lot of functionality necessary to having functionality that would be useful in those consumer and industrial products. And I'll share some examples of the type of chemistry that we practice a little bit later on. So again, being in the middle there provides a lot of opportunities to influence what happens in that value chain, but also, again, a key theme to just keep in mind for today is we also have a lot of pressures and challenges that come with both the upstream side of things from a sustainability perspective, as well as the expectations of our customers and end users in society for what our specialty chemicals and our products may impact. So I want to talk a little bit on this slide about some of those pressures. And there's significant overlap, and I recognize that it's much more complex than depicted here, but I hope that this represents and is able to depict some of the challenges that are seen across the chemical value chain. So on the left-hand side, when you think about commodities, the starting point of raw materials historically, when we think about accessing palm or using agricultural materials as commodities for chemical processing, there's the questions of food versus fuel, and certainly human and labor rights, as we see in many parts of the world, and how those chemicals or how those commodities are accessed in the supply chain. There's certainly land, water, and environmental impact that you think about crop-based commodities, as well as petroleum and the influence on the environment. As you move further up the value chain, basic chemicals converters and manufacturers have key concerns that include process safety. There have been in the news recently several manufacturing site incidents in Europe and the US that have raised significant concerns, not only for human safety, but also on environmental outcomes in the land and water surrounding those manufacturing and often very large manufacturing sites. I'll talk a little bit about greenhouse gas emissions, and I'll focus on this slide here to give everyone a sense of, in the United States, what the greenhouse gas emissions profile looks like for the chemical industry. So on the left-hand side, there's data from the US EPA on emissions reported in the years 2011 to 2019 for various basic chemical processing, as well as further downstream processing that's represented more or less in the yellow line there. So one thing just to point out is, this is some pretty significant emissions that we're talking about here, and especially focused on some of the commodity and basic chemical conversions and processes that take place. On the right-hand side is data from the American Chemistry Council. It's a little bit of an infographic that shows the greenhouse gas as well as the financial impact of the chemicals industry in the US. And I'd just like to note for the greenhouse gases, the chemical industry it's a non-trivial contributor, and you can see that the energy use in processing chemicals is actually the most significant contributor to the total emissions. And this is just something that highlights the complexity of thinking about energy and emissions in a more holistic way, that it's not so much what's coming out of the stacks, so to speak, that is contributing to the emissions. The energy it takes to carry out chemical processing and the other emissions related with production also have a role to play. So I just want to share some of this background just to give you a sense of the contribution of chemical manufacturing to greenhouse gas emissions in the US, and then a little bit of the breakdown of where it comes from in the processing. So if I go back to this slide, thinking about the customers and users downstream of specialty chemicals. So companies like Stepan are customers who turn our products with other components into formulated goods, take part into the emerging e-commerce network and get products in the hands of people who use them in industrial or consumer applications. You see a different spectrum of pressures that they're under. And I think you're probably familiar, everyone here is probably familiar with some of these. Plastics and packaging, the addiction on plastics in society to carry goods and to, again, have the challenges of how we recycle and reuse currently in many parts of the world at a very low rate. Water and energy use. This is something that does cut across the value chain, but when you think about laundry and washing clothes, what are the more efficient ways that water and energy use can be applied versus our historical and current state? And then when you think about consumer goods and goods that are used for household applications and industrial applications, they have to move. And they need to be transported across distribution channels by rail, by car. And then you see what has happened with e-commerce, that Amazon trucks, UPS, FedEx trucks are ubiquitous. So there's fuel, there's a lot of concerns about emissions that come from that additional transport that takes place. And then on the right-hand side, you see, if I could smooth over, the right-hand side, you could see what are the concerns at end use or end of life for the products that are part of the chemical value chain. Biodegradation. So you think about consumer products or products that cannot be recycled or reused. What is their environmental fate? Do they further degrade into microplastics, which is really getting a lot of attention, especially in Europe, and that's going to be again an area that globally is going to be of growing concern as well as regulation. And then also product safety. Are the products that are being used by consumers safe? What is their profile? What are their long-term effects? All of these are sustainability pressures that hit across the value chain. And the point I want to make about specialty chemicals is really we fall under the influence and the challenges from all parts of the value chain to hopefully make improvements and a more favorable environmental and societal impact. But all of this comes to us in one form or the other, either in our supply chain upstream or how our products can influence the outcomes downstream. I would like to make mention of the topic of circularity. So what I show in this slide is really linear. And I'll talk a little bit more about circularity in one of the projects and product areas that we're focused on at Stepan a bit later on. There's a lot of attention in the chemical value chain to have a greater ability to recycle and reprocess materials for multiple useful physical or chemical lives. And for simplicity, really, I'm just showing that this is the value chain in linear form. But when you think about some products that specialty chemicals manufacturers like Stepan produce, there's no simple or aggregated way of recovering materials to support circularity. When you think about shampoo or you think about dishwasher detergent, you think about coatings for painting and so forth, they will have an environmental fate, and it's not easy on a product basis or certainly on a molecular basis to recover them back into a circular stream. So when you think about the right-hand side of this slide, biodegradation, product safety, environmental fate become all the more important because that ability to reuse and be part of a circular economy is not easy to accomplish. So I'd like to make a couple of summary points here. First, there are diverse pressures and challenges to improve the environmental and societal impact of the benefits of chemicals across the value chain. And that's going to require innovation, investment, and partnership. Second, specialty chemicals companies perhaps have some of the most highest level of complexity to address these issues, but we also have significant opportunity to influence them downstream if our products, operations, and business models can respond to emerging needs as we see them continue to evolve. So a few other challenges on specialty chemicals. First, carbon sourcing. For companies like Stepan, what will the future of raw materials be? How will we continue to make decisions on food versus fuel for bio-based raw materials? Will chemical recycling and repurposing be successful and be done across geographies? There are sustainability trade-offs. What if you have a petroleum-derived product that provides high performance and lower use rates, lower energy usage downstream? Is that more environmentally friendly than bio-based solutions that don't perform as well? There are supply chain limitations. Raw materials with good environmental profiles may be available, but costs or logistics may not be favorable for a company and their manufacturing and distribution network. Green solutions don't always mean products. We'll talk a little bit about product development and design later on, but especially chemical may provide an environmentally friendly profile, but it doesn't mean it's going to work as an agricultural formulation or a dishwasher detergent or in paint, for instance. So the innovations around sustainable solutions also need to be considered in the context of products down the value chain and the business models that will be successful around them. And I mentioned circularity earlier, and again, this is really important to specialty chemicals to think about. How can we participate in circularity processes when many of our products are consumed and go into the environment? So the challenges for specialty chemicals manufacturers are significant, really important part of the overall value chain in commerce, but a lot of challenges to address. So I'd like to pivot now and talk a little bit about Stepan Company and some of the work that we're doing to try to step up to those challenges that are out there for the chemicals value chain as well as specialty chemicals more specifically. So we're a company based near Chicago, but with global operations. And we have, I'd say, three categories of market focus: surfactants across a wide range of applications, polyester polyols for insulation and other purposes, and specialty products for food and nutrition. We're about a 90-year-old company, always based in the Chicago area. And as I mentioned earlier, we're a global business. We have 20 manufacturing sites, so pretty significant footprint and capability across the world. And our R&D team has 14 laboratories that are across different regions. And as mentioned earlier, we're a proud member of the Emory RSC. And on the right-hand side, you see one of our three facilities in Georgia. This is our Agricultural Innovation Center. It's next door to one of our manufacturing sites. And we're really excited to host an Emory RSC event this month. It's going to be postponed a bit due to COVID, but we really look forward to rescheduling in the future and looking forward to other opportunities to collaborate with the Emory community and other stakeholders in Georgia. A little bit about sustainability at Stepan. We have a continually expanding emphasis on sustainability, and the focus is really in four pillars of people, planet, products, and practices. And these cover what, again, you consider environmental, social, and governance considerations for a company like ours, and satisfying the needs and really making progress on all three of those fronts for all of our stakeholders and society. And certainly from a people perspective, focused on the communities that we serve and the safety and well-being of the people who use our products as well as our employees, efficiency for the planet, and always trying to optimize and improve our operational footprint, and to use science-based information to have goals that are meaningful that we look to achieve. From a practices perspective, thinking about our corporate governance and also thinking about all of our business decisions and our strategies to promote resilience, agility, and responsible practices. But in the coming slides, I'm going to focus a little bit more on products and some of the chemistry that we focus on and some of the ways that we look to improve the sustainable profile of our offerings as a specialty chemicals company. And one thing before I go further, this is work that's really representing a lot of great people in the Stepan R&D team and our partners. So just want to make sure that acknowledge and thank everyone whose work is going to be described here. So in the examples I'll describe in the coming slide, we'll focus on a few of the ways that we're focused on some of the challenges that the chemical value chain and specialty chemicals companies have. Alignment to UN Sustainable Development Goals, moving towards more concentrated or compacted products, holistically designing products with sustainability considerations in sight from the start, bioprocessing, and circularity. So first, Stepan's products and position in the value chain, just think back to that cartoon that I showed of the value chain being right in the middle. We're really well positioned to influence and make positive impacts against UN Sustainable Development Goals. And I hope everyone's familiar with UN SDGs. If not, there's a lot of great information to access to understand how the UN is driving companies and institutions towards alignment on on 17 goals. We've done an analysis that at least 75% of our products have a strong alignment just to 4 UN SDGs that are shown on the left-hand side. Of course, we want to do even better, and we're integrating UN SDG alignment as a criteria for assessing our innovation projects and also our products across different markets that we serve. But you see some of the areas, specific areas that Stepan participates in agriculture, cold storage with insulation, sanitation and disinfection, as well as supporting renewable energy processes. And we're really proud to be part of products and industries that are supporting UN SDGs, but we know there's a lot more that we can do. In addition, our operations and sourcing of the company has a continually growing focus on responsible consumption and production, leading to investments in emissions reduction, as well as a really clear focus on raw material sourcing and how we can be traceable to ensure the right ethics and compliance in the materials that we use. So in this slide alone, you can see that companies like Stepan can drive really important improvements that are aligned to these critical goals that the UN has articulated in the SDGs. So we look forward to continuing to use the UN SDGs as a North Star in our innovation and development work. So I'm going to share some specific examples in the next slides. This is an example relating to fabric softeners from our consumer products R&D team. And the focus on this work is really technical solutions for more concentrated fabric softener products. Typically, fabric softeners, they're cationic molecules, and they're formulated in liquids at pretty low concentrations, maybe 10% or so, and a lot of water. And when you think about having a lot of water that you're shipping around, that will take a lot of plastic packaging to hold, there are pretty significant impacts when you think about the environment and what happens downstream in the value chain. So our team is focused on developing a formulation technology, both concentrated liquids, as well as solid powders that increase that concentration of the products by 5 times or more. In this instance, at least 70% liquid is shown in the top left-hand corner. One thing that's really important, and this is again a key focus of being successful in having more sustainable products, is they have to work. So the products, the concept that we developed here, the technology that we developed here, retain the high performance in softening applications. And importantly, they could be readily processed by our customers down the value chain. So rather than having to apply a lot of energy and heat to reconstitute a wax or a solid, our customers are able to formulate and use less energy in their processing and take that down the value chain with a lower environmental impact. So what does all this mean? On the right-hand side, you see some of the potential impacts if fabric softeners moved from a lower concentration format to a more concentrated solution. And you see the impact on potential shipments, so 200 times less use of fuel versus the current requirements for low concentration fabric softeners and shipping them around. 25,000 metric tons of plastic that could be saved, and also 250 Olympic-sized swimming pools in terms of just water savings in the product. So, we like to look at these types of examples to illustrate the impact that moving from, again, a lower concentrate form to something that really delivers the same product benefits that using chemistry and formulation technology can provide to improve the sustainability profile. I think we have a lot of chemists on the line today in this meeting. So for those of you who are not, I hope it's okay to show a chemical structure too. Next couple of slides, I want to talk about thinking about sustainability from a holistic product design perspective. And this is an example of what we call, again, another cationic molecule called an ester quat that's also used for fabric softening purposes. But we worked on this product in partnership with a company called Henkel, a rather large consumer goods and diversified company. And we worked with them to try to achieve a number of sustainability goals, but had to really work from first principles to design it right. And so some of the key things that we had to focus on were the sourcing of the raw materials for the components, having some specific claims like vegan claims for that raw material sourcing for a bio-based product. And then also, again, meeting the performance requirements, consumer expectations, and safety. So a little bit about the Chemist Chemical. It's a cationic or positively charged molecule. And it includes what we call an ester functionality on the left-hand side. And this ester functionality provides a type of degradation in the environment after use that's more favorable versus other types of, or older types of chemistries. And importantly, again, this molecule, this type of molecule is really effective in softening performance for fabrics. But again, has that degradation that's really important. Historically, some of these products are based on fatty acids that come from tallow or animal-based oils. So we have been a leader in converting towards vegetable-based versions. And importantly, again, the team worked with our partner to design a product from early stages to meet key requirements rather than incorporating sustainability considerations later in the development. So we looked for ways to have bio-based and vegan sourcing for the critical fatty acid component, and also having locally derived or locally accessed rapeseed oil to use for this process, thus reducing the logistics and fuel impact versus alternatives from maybe more tropical vegetable oils. So we were able to meet the performance requirements down the value chain and improve the sustainability benefits versus incumbent products. Another example, and on the theme of cationic surfactants here, but another example of holistic product design connects to our focus on biorenewable carbon. Stepan has a long-standing focus on a concept called Biorenewable Carbon Index. And this is the way that we characterize our products in terms of the percentage of bio-based carbon to provide a measure and assessment for our customers as they formulate and look to meet sustainability goals or particular targets for bio-based materials to be able to formulate and develop the products with this measure in mind. So it's a semi-quantitative measure in a sense, but again, a good sort of rubric to be able to further down the value chain assess how close you are to some of your goals on bio-based products. I'll talk a little bit more about quantitation of life cycle a bit later. In this product, another ester plot, we have a hair conditioner in this case called Stepan Soleil. That's similar to the prior example, incorporates bio-based fatty acids that are flexible in terms of sourcing and processing depending on the region of production. So for North America, perhaps the use of sunflower oil. In Europe, rapeseed oil can be used. So you could still have that local sourcing in this concept. And these products are formulated as liquids. And again, a lot of products, if you used hair conditioners, you know they're a bit waxy, have a fatty feel to them. Often they're delivered as low melting solids and they require heat for processing. And what we've done is incorporate a formulation technology to be able to keep the products liquid, easy to process, and again, down the value chain, use less energy to process into the end consumer product of a hair conditioner. So from the molecular design and raw material sourcing, formulation processing, our team assessed different options holistically and really looked at critical sustainability parameters to target while still maintaining product performance. Next couple slides, I want to talk a bit about biosurfactants. So far I've talked about surfactants that are manufactured through chemical processing. There is a growing interest in commercial opportunities evolving for biosurfactants. And these are compounds that are either substantially or fully bio-derived, through extraction of natural materials, or more preferably, manufacturing through bioprocesses like fermentation. And through the years, there have been some biosurfactants that have been commercialized that incorporate carbohydrate or amino acid components. They've been commercialized and utilized across the value chain. But broadly, this class of surfactants has had the challenge of having high cost profiles, or maybe not having performance that is equivalent to chemical derivatives, and thus don't always fit the needs of the downstream consumer companies, industry companies, and certainly the end users. However, their sustainability profiles, including biodegradation, as mentioned earlier, are really becoming important factors and really attractive. And more and more, the application opportunities, as outlined on this slide, as well as their cost profiles, are improving. So Stepan is investing in a very promising area of biosurfactants, specifically a chemical called rhamnolipids. And these are naturally present surfactants that are produced by Pseudomonas aeruginosa, as well as other strains that are genetically modified by bioprocessing, but they do naturally occur in the environment. We're exploring a range of applications downstream for rhamnolipids. These molecules really have beneficial properties that relate to emulsification, foaming, other applications that were noted in the prior slide, like bactericidal properties, biofungicidal properties. And importantly, these compounds can be manufactured, fermented from naturally sourced materials, and they're highly biodegradable and have a really excellent environmental fate profile. Now, an important challenge for Stepan and other companies like us to address, to ensure that these technologies make their way downstream the value chain, is to make sure that they can be scaled, and that they can be scaled at a cost that will help them replace incumbent technologies while still maintaining the performance needs. So that's one of our key challenges that we're focused on as an R&D team right now at Stepan. We're focused on scaling our process and moving to the plant that is shown on the right-hand side of this slide, which is in Louisiana, to be able to produce rhamnolipids and hopefully in the future other biosurfactants at a world-class scale to supply the future biosurfactants that are going to make up a lot of products in the value stream down in the future. So we're really excited about this technology. We do believe that fermentation and the biosurfactants class is going to be more and more critical and will be more used across industries in the years to come. And we're really committed to taking this forward and succeeding. The slide I want to talk briefly about circularity. Stepan not only manufactures surfactants, but also polyester polyol products. And these are products that have aromatic groups that are foundational components for lightweight polyurethane and polyisocyanurate foams that are used in durable goods, as well as in cars and cold storage, for shipping, preserving foods, for safety and protection, and also for building insulation products. So these chemicals provide important energy savings, and they're really wide-ranging in their applications. So you see here in the pictures some rigid roofing boards on the bottom left, as well as spray insulation, one of our R&D team members on the right. Using products like spray foam actually can reduce energy usage in buildings by up to 30%. And again, this is a key focus, as Barry mentioned earlier, on hopefully our infrastructure path moving forward in the US and having more energy efficient building envelopes and save fuel and emissions. These polyester polyol products also allow for increased use of recycled materials. So you can recover materials such as plastic bottles with polyethylene terephthalate. There's also a focus on other materials that otherwise would go to landfill, like mattresses, and reprocessing them, re-esterifying them, and then incorporating them into products that could then be used in the building envelope, while still maintaining energy efficiency requirements and fire safety requirements in the buildings. So there are a lot of opportunities in this sector to take raw materials or recycled materials rather, pull them together with freshly produced materials, and again, make a favorable environmental impact using materials, again, that otherwise would be incinerated or go to landfill. A really important point about circularity, though, is this sector is going to largely depend on aligning logistics and reprocessing capability. So there's a lot about where materials can be aggregated and reprocessed and then converted eventually. You can imagine that having a circular product profile is great, but if you have to ship products across the world, that's not so favorable. So really you have to think about this holistically, where we're at in the value chain. Specialty chemicals companies can really understand what the opportunities are. So finally, again, I provide some examples of how Stepan and where we're at in the value chain, how we can make improvements in the sustainability profile of our products and what happens down the value chain. Aligned with these specific products and projects and technologies I've talked about, we're also developing a holistic tool that integrates a wide range of information, including environmental data, emissions, energy input, but also regulatory and compliance data on our sourcing, to bring together an overall view to assess whether we're truly making improvements versus incumbent technologies. And again, this requires a lot of data, a lot of understanding of the impact, the life cycle impact of your products. But we think it's a really important way for us to work with our partners upstream in the value chain and downstream in the value chain to make the improvements that are needed in the chemical industry and the products that go out to end users. Again, this is really important, and again, I think a responsibility for all companies to understand their environmental profile of their products better, find ways to improve, and partner with other companies and institutions to innovate and develop new solutions. So with that, I'll just close with, again, a few words. Specialty chemicals, I hope I've shown that we've got multiple challenges, but also a number of different ways in our products to support sustainability and improved environmental outcomes. There are plenty of challenges present across the value chain. This is not going to go away. It will only intensify. But innovation partnerships, new business models are going to be key to ensure that progress continues and we can make meaningful environmental impacts. So I'd just like to thank a few folks. Charlotte Bryant, who leads our sustainability steering team and who is a great partner in my team and really is also prepared a lot of the content we saw today. I'd like to thank the Stepan Marcom and sustainability steering team, as well as the Stepan R&D team, whose examples I spoke to today. And finally, I'd like to thank the Emory RSC, David Lynn, Professor David Lynn. Thanks for connecting Stepan to the RSC. We're really proud to be associated with the team. Professor Isakawa, thank you again for the invitation to speak today and for your collaboration, and Ms. Leah Thomas for helping coordinate the talk. So with that, I'm happy to answer any questions, and I'll stop sharing from here.
Thank you so much. This was so great. And I wish everybody could be clapping at the same time. I just wanted to say, I'm so sorry that I forgot to mention about Stepan, one of the very important details of the Stepan that I really wanted to tell everybody about is that Stepan Company is actually ranked 84, if I remember correctly, in the Wall Street Journal's most sustainably managed companies in the world. And so if you had not heard of them, I hope you know now. I don't know if the link worked very well, it doesn't seem like it, but if you Google, you will be able to find that. And there was a request for the transcription during the talk, and so I turned it on. I hope that did not bother you too much, Jason. I apologize if it happened too suddenly, but I hope that helped some of the folks that were here. So with that, I want to open up for questions. There is already a question coming in, so I will start off with Keenat's question. Is the biorenewable carbon index that you mentioned a Stepan innovation, or are others using that index? If a Stepan innovation, are there ways to expand the reach of this concept to include products made by other manufacturers?
Yeah, it's a great question, Tina. And I think it's a tool. We developed it as a way to express what we felt was helpful for our customers to see the biorenewable content and the impact. Other companies have some similar tools. I wouldn't say there's a universal approach to it. And that is, again, a key question moving forward. And you know, in that one slide about our sort of profiling tool that we're developing, more and more there's an expectation to move from, I would say, more qualitative measures to more quantitative measures. And taken to the extreme, you know, full life cycle analysis of products is a very rigorous and time-consuming and data-intensive process. But more and more, that's likely going to become an expectation for a lot of products as they move, again, from one end of the value chain to the other. But our BCI is more of a tool or a rubric, I would say, and we're moving, again, we keep that as a tool. Others have similar, but we're moving more and more towards a quantitative approach.
Great, thank you so much for that. Keena, did you have a follow-up question?
No, that's great. Thank you so much. I guess I do in a way, though. Jason, if there's time, and I don't want to jump the line on other questions, but I would love to hear more. I just applaud your work on the SDGs and was particularly excited to see Zero Hunger listed. And I just wondered if you could say another word about what you're doing to enhance agricultural efficiency and cold storage in other ways. Thank you.
Yeah, thanks, Kenneth. So, you know, we have a long-standing commitment and participation in crop protection and agriculture. More and more, we're going to be focusing on topics like soil health, and there's a lot of focus on regeneration there, but also having more precise application of products. So as agricultural products are applied into fields, they often can spray out into the environment. A lot of the materials that are intended to boost crop protection or support plant protection end up elsewhere on the soil, in water. So a lot of the technologies that we focused on are trying to ensure that the products that are applied will get to where they ought to be versus out in the environment. That includes formats like seed treatments, where we apply materials specifically on seeds so that they can, again, in many applications, move away from sprayed products. From the cold storage perspective, we're very much involved in that on the polymer side of things with the insulation products. And we see in emerging economies, I know China is not really considered an emerging economy at this point, perhaps, but you see that they're building up their cold storage food chain from, I would say, a pretty limited capacity. And you see, again, the migration of rural to urban, and what are the implications as far as the food chain there. So we are participating quite a bit in the cold storage chain in China to help get that infrastructure better in place for the population moves that have happened.
Great, thank you so much. David, do you want to ask your question, please?
Yeah, yes, Jason, thanks so much. That was really great. I was wondering about, you know, the circular economy and the input of natural materials in that. Where do you see major limitations of those opportunities existing, and how might those be addressed?
I think in principle, David, you know, if you think about it just from a chemical perspective and what can be recovered and reprocessed, it's almost agnostic to whether something is natural based or not. You know, and I've probably thought more about organics versus, you know, mined materials and organics and so forth. But in principle, you know, there should be some, you know, an agnostic approach to whether something is an ester that could be recovered and recycled coming from a circular approach or coming in fresh virgin material. I think, again, one of the challenges is, what will give the most benefit? And I think that's where, again, you have to look at things holistically. Where are you sourcing material? Are you going to have to ship something really far across the earth just to achieve circularity? Or do you have a solution that might be a little bit more expensive, but will reduce the environmental footprint? So I think the key thing is looking either end to end from a value chain perspective, or looking around the circle for circularity to understand the knock-on effects and where, again, you have to make trade-offs. I think it comes down to trade-offs and really understanding the profile of each of the products that are constituting that full life cycle.
I do like the way that Stepan is used materials like the rapeseed, use materials that grow in a certain area for the products in that area. I mean, that suggests that things are become more and more local. Is that the way you see companies evolving in terms of the way they do their chemistry and the way they connect to the commercial market?
I think it's a great aspiration. I think, we've seen, this year, across the world, supply chain disruptions where companies have had to find alternative sources, and maybe, again, that's very disruptive to that aspiration of local sourcing. But I think as governments and companies start to focus on net zero or reduced emissions or science-based targets, we're going to have to find those wins. We're going to have to find those abilities to reduce our footprint. And again, I think strategic sourcing, thinking in geographical terms, logistically, and again, maybe just going back to my first slide, it's not just about making things, it's about making things more sustainable. So having that as part of your sourcing strategy and innovation and development strategy is going to be really important. But I think we're probably not well suited to do that for everything at this point.
Yeah, that's great. Thank you.
Yeah, thank you so much. Please, if you have a last minute question, please put that on the chat, or you're welcome to also raise the hand so that I can give you the mic to you. But if not, I just wanted, oh, there you go. Okay. Matt asks, Matt, do you want to speak by yourself or do you want me to read?
Either way.
Go ahead.
So first of all, I was really excited to hear you were speaking because I was an undergrad chemistry major at Notre Dame and spent lots of hours in Stepan Chemistry Hall in onerous AChem labs. Anyway, but that drew me in. Last semester, I happened to do a project with a global specialty plastics company, and we were helping them investigate greenhouse gas accounting and GHG reduction strategies with internal cost of carbon. And we really hit the wall because they were in different countries with different taxation regimes, and it got really messy. And I just wondered if you have any advice for GHG tracking or reduction strategies.
Yeah, that's a huge challenge. And I think, Matt, what you pointed out is that, frankly, sustainability is shifting a little bit or broadening to a data and finance type of consideration. So and that's, to be very honest, that's one of the challenges that we have in our company to say, if we look to have certain targets, what are the different levers that you have, and can you measure them, right? So that's exactly what you pointed out. And so carbon capture, carbon sequestration technologies, there are different things. But, one is kind of like a financial or accounting tool. Other is, technologies. I think we have to look across the patch, and it's all towards having targets that, again, are meaningful and that you look to achieve. So I'm not sure if I have great advice for this specific issue, but again, recognize that more and more it's less about just the chicken wire, the chemistry, so to speak, and the processing, but all the other considerations. Is your business model aligned to, or do you need to reconcile your business model and your manufacturing and distribution network and your customers' scope 3 emissions and so forth to your targets? And it's a really challenging and complex area, and it's only going to get more challenging.
So if there's another question, is it okay, Jason, to have another? Actually, there are more questions coming in. I think chemists are very shy, and I think your talk really made us think a lot. And so the questions are coming in a little bit later than usual. But is it okay to continue going with 2 more questions?
Sure thing, happy to.
Great. Laura, did you want to speak up yourself?
Yeah, so what I wanted to check in is in terms of contributing to zero poverty, how are you going about local sourcing since you have global presence? What are some challenges you have met, and what are the processes you put in place to ensure local economy participates?
Yeah, it's a great question, Laura, and and I think that's where we probably have some limited options to at this time to make an impact. Part of what we do is participate in sourcing consortium like responsible sourcing for palm oil to make sure that as we go back in our supply chain that there's ethical sourcing. If there are issues, that they could be traced and acted upon. We don't have as many, I would say, diverse vendors in terms of packaging and materials and so forth as some of our downstream customers and partners have. So you'll see a lot for consumer groups that they have a lot of close connectivity and are diversifying their sourcing to support various communities and emerging vendors in different materials and products that can be built into their goods that are sold to end users. So we're a little bit limited on that, but I would say the primary way that we focus on that is through our responsible sourcing activities and how we, again, track and trace and act when issues come up. Ultimately, we would like to move towards a more proactive approach versus just monitoring.
Okay, so maybe I'll connect with you offline. That's a very fair answer that you have given, because from a governance point of view, it will be very hard to actually say this is the touch point of contributing to zero poverty. But if you're working through consortium, for instance, palm oil, I don't know which country is the greatest contributor. I know Nigeria has a lot of palm oil, but also there are questionable approaches in terms of how you get it. But thank you so much. I'll connect with you offline and then we can take it further.
I look forward to it. Thank you for your question.
Thank you so much, Debjani.
Sure, I can go next. Hi, Jason, great talk. I was just curious, like, are there any life cycle analysis for any of the specialty chemicals that I have seen? I was particularly interested for those applicants in agriculture, like the biosurfactants, because now we are in the era that we are trying to capture carbon in soil, like improving soil health, and a lot of the discussion goes back is like we can see the health is improving, but at the same time there are a lot of processing that goes behind the story, and how do you deal with that in the sustainability perspective?
It's a great question, and one that we get more and more from our customers down the value chain. The answer is I would say we are working on it. We're developing the capabilities and especially the data access. So whether it's a more formal life cycle analysis like the GABI methodology that some of you may have heard of, or the profiling tool that we have, it's accessing data that we sometimes either haven't measured or we need to access from our suppliers. When you think about a full life cycle analysis, can we get the data that we need from our suppliers similar to what our downstream customers are asking for? So I would say for us, it's a work in progress, and really it's about bringing the data together, accessing the data, and certainly for our biosurfactant platform, we do anticipate having rigorous life cycle analyses, because we want to be able to understand where we can optimize and improve those processes. They are based on natural fermentation processes that occur. But they do require energy. They do require inputs. There are emissions with fermentation processes, as we know. So a full life cycle analysis is going to be important for us to be able to credibly say that our products do have an advantage, a sustainable advantage. You see companies stating that they plan to have a certain number of life cycle analyses done by a certain time. I know of one competitor, at least, who's doing that. And what you see is that, yeah, it does take time if you want to get all of the data together and not just do it back of the envelope. So that's something that we're building more and more capability in. And a lot of it is just that ability to measure and access data to pull it together.
Thank you.
Oh, thank you so much, Jason. And thank you everybody for all the great questions. I feel like Zoom is so great because we can actually get together even though Jason is in Illinois. But at the same time, I really wish we were actually at the same place so that we could ask you more questions. You know, getting together would be really nice. So I hope that we will be able to do that soon at the Winder facility. And I really invite everybody to come when we are able to get together there with less COVID cases. So thank you so much, everybody. We are going to continue with the seminar series in September as well. So I hope you will come back. And well, let's thank Dr. Keiper again, virtually or with the actual clapping. And stay safe and healthy, everybody.
Thanks, everybody. Thank you, Erin. Have a great day.
Thank you so much.